The scenario involves underground gas and diesel piping passing through a plastic sump, which is Underwriters Laboratories listed, and contains solenoid valves. These valves control the flow of fuel, but there is no fuel usage within the sump itself. This situation necessitates a careful evaluation to determine the appropriate hazardous location classification according to the National Electrical Code. The correct classification for this environment is Class 1, Division 2, Group D. To understand this classification, we must first define each component. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 locations are those where flammable gases or vapors are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Group D includes atmospheres containing gasoline, hexane, naphtha, benzene, butane, propane, alcohol, acetone, benzol, lacquer solvent vapors, or natural gas. Now let's delve deeper into why this specific classification applies. Firstly, the presence of underground gas and diesel piping inherently introduces the risk of flammable vapors. Although the fuel is contained within the pipes, the possibility of leaks, ruptures, or failures exists. This potential for the release of flammable substances is the primary reason for classifying the area as Class 1. Secondly, the solenoid valves within the sump are crucial components in controlling the fuel flow. While they are not actively using fuel, their operation and potential malfunction can lead to the release of flammable vapors. The sump, being an enclosed or partially enclosed space, can accumulate these vapors, creating a hazardous environment. Therefore, the area is classified as Division 2, indicating that the risk of flammable vapors is present but not under normal operating conditions. Thirdly, Group D is assigned because the fuels involved, namely gasoline and diesel, fall under this group. Group D encompasses a range of flammable substances, and it is essential to select equipment and wiring methods suitable for this specific group to prevent ignition. In practical terms, this classification dictates several critical requirements for electrical equipment and wiring within the sump. Firstly, all electrical equipment, including the solenoid valves and any associated wiring, must be approved for Class 1, Division 2, Group D locations. This means that the equipment is designed and tested to prevent ignition of flammable vapors under normal and abnormal operating conditions. Secondly, wiring methods must comply with the National Electrical Code requirements for Class 1, Division 2 locations. This typically involves using sealed conduit systems or other approved methods to prevent the ingress of flammable vapors into electrical enclosures. Thirdly, regular inspections and maintenance are essential to ensure the continued integrity of the piping, solenoid valves, and electrical equipment. Any signs of leaks, corrosion, or damage should be promptly addressed to prevent the accumulation of flammable vapors. Furthermore, it is important to consider the ventilation within the sump. Adequate ventilation can help to dissipate any accumulated vapors, reducing the risk of a hazardous atmosphere. However, even with ventilation, the area may still require classification as Class 1, Division 2, Group D, depending on the effectiveness of the ventilation system. In addition to the National Electrical Code requirements, it is also crucial to consult with local regulations and fire codes, as these may impose additional requirements for hazardous locations. Proper documentation and labeling of the hazardous location are also essential to ensure that personnel are aware of the potential risks and take appropriate precautions. The Underwriters Laboratories listing of the sump indicates that it has been tested and evaluated to meet certain safety standards. However, this listing does not automatically guarantee compliance with hazardous location requirements. It is still necessary to select and install equipment and wiring methods that are specifically approved for Class 1, Division 2, Group D locations. The classification of Class 1, Division 2, Group D is not a static determination. It should be periodically reviewed and updated as necessary based on changes in the operating conditions, equipment, or materials used within the sump. For example, if a different type of fuel is introduced, the group classification may need to be revised. In summary, the presence of underground gas and diesel piping, combined with solenoid valves within a plastic sump, creates a hazardous environment that requires careful classification and adherence to the National Electrical Code requirements. The appropriate classification for this scenario is Class 1, Division 2, Group D, which necessitates the use of approved equipment, wiring methods, and regular inspections to prevent the ignition of flammable vapors. Remember to consult with qualified electrical professionals and local authorities to ensure compliance with all applicable regulations. The National Electrical Code provides detailed guidelines for electrical installations in hazardous locations, outlining specific requirements for equipment, wiring, and other safety measures. These guidelines are designed to minimize the risk of explosions and fires in areas where flammable gases, vapors, or dust may be present. It's crucial to thoroughly understand and adhere to these guidelines to ensure the safety of personnel and property. Moreover, proper training for personnel working in or around hazardous locations is essential. Training should cover the identification of potential hazards, the use of appropriate safety equipment, and emergency response procedures. Regular refresher training can help to reinforce safety practices and keep personnel informed of any changes in regulations or procedures. When selecting electrical equipment for Class 1, Division 2, Group D locations, it is important to consider factors such as temperature rating, ingress protection, and resistance to corrosion. The equipment should be designed to withstand the environmental conditions present in the sump and to prevent the ignition of flammable vapors under both normal and abnormal operating conditions. Wiring methods for Class 1, Division 2, Group D locations typically involve the use of sealed conduit systems such as rigid metal conduit or intermediate metal conduit with explosion-proof fittings and seals. These conduit systems are designed to prevent the propagation of flames or explosions from one area to another. Alternatively, cable systems that are specifically approved for Class 1, Division 2 locations may be used. These cables are typically designed with a rugged outer jacket and internal barriers to prevent the escape of flammable vapors. Proper grounding and bonding are also critical in hazardous locations. Grounding provides a path for fault current to flow back to the source, helping to prevent electrical shock hazards. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current, minimizing the risk of arcing or sparking. In addition to the electrical system, other potential sources of ignition should also be addressed. This may include eliminating or shielding hot surfaces, using non-sparking tools, and controlling static electricity. Regular monitoring of the atmosphere within the sump can help to detect the presence of flammable vapors before they reach dangerous levels. This can be accomplished using fixed or portable gas detectors that are calibrated to detect the specific fuels involved. If flammable vapors are detected, appropriate actions should be taken, such as shutting down equipment, ventilating the area, and investigating the source of the leak. Emergency shutdown systems should be installed to quickly de-energize electrical equipment in the event of a hazardous condition. These systems should be designed to be fail-safe, meaning that they will automatically shut down equipment if there is a power failure or other malfunction. Furthermore, it is advisable to develop and implement a comprehensive hazardous location management program. This program should include procedures for hazard assessment, equipment selection, installation, inspection, maintenance, and training. The program should be regularly reviewed and updated to ensure that it remains effective and compliant with all applicable regulations. In the context of underground fuel piping, it is important to consider the potential for soil contamination in the event of a leak. Soil contamination can pose a significant environmental hazard and may require remediation. Therefore, leak detection systems and spill containment measures should be implemented to minimize the risk of soil contamination. The use of double-walled piping can provide an additional layer of protection against leaks. Double-walled piping consists of an inner pipe that carries the fuel and an outer pipe that acts as a containment barrier. If a leak occurs in the inner pipe, the fuel will be contained within the outer pipe, preventing it from reaching the surrounding environment. Cathodic protection systems are often used to protect underground metal piping from corrosion. These systems involve applying a small electrical current to the piping to counteract the effects of corrosion. Regular inspections of the cathodic protection system are necessary to ensure that it is functioning properly. In addition to the technical aspects of hazardous location classification, it is also important to consider the human factors involved. This includes ensuring that personnel are properly trained, equipped, and motivated to work safely in hazardous locations. Clear communication and coordination are essential to prevent accidents and incidents. Finally, it is worth noting that the classification of hazardous locations can be complex and challenging. It is always advisable to consult with qualified electrical professionals and local authorities to ensure that the appropriate classification is assigned and that all applicable regulations are followed. Understanding the nuances of Class 1, Division 2, Group D involves considering factors beyond just the presence of fuel. The likelihood of a flammable atmosphere developing under normal and abnormal conditions plays a significant role. For instance, if the solenoid valves are hermetically sealed and regularly inspected, the probability of vapor release decreases, but the classification still applies due to the inherent risk associated with fuel transfer. The selection of equipment also considers the ambient temperature range within the sump. Equipment must be rated to operate safely within the maximum and minimum temperatures expected in that environment to prevent overheating or malfunction, which could lead to ignition. The NEC, specifically Article 500.5, provides detailed guidance on the characteristics of different hazardous locations, aiding in proper classification. Additionally, Article 504 addresses intrinsically safe apparatus, which, if used, can reduce the risk of ignition by limiting the energy available to spark. The installation of grounding and bonding systems must adhere strictly to NEC Article 250, ensuring that all metallic components are effectively grounded to minimize static electricity buildup and provide a path for fault currents. Emergency procedures should include protocols for isolating the fuel supply, shutting down electrical equipment, and ventilating the area to reduce vapor concentrations. Regular drills and simulations can help personnel become familiar with these procedures and respond effectively in the event of an emergency. The specific requirements for conduit seals in Class 1, Division 2 locations are detailed in NEC Article 501.15. These seals prevent the passage of gases, vapors, or flames through the conduit system containing any potential explosion within a limited area. Furthermore, it is important to document all aspects of the hazardous location classification, including the basis for the classification, the equipment selected, the wiring methods used, and the safety procedures implemented. This documentation should be readily available for inspection and review by regulatory authorities. The presence of signage indicating the hazardous location classification is essential to warn personnel of the potential risks. The signage should clearly state the class, division, and group, as well as any other relevant information such as the type of fuel present. The implementation of a management of change process is crucial for ensuring that any modifications to the piping system, electrical equipment, or operating procedures are properly evaluated for their potential impact on the hazardous location classification. This process should involve a thorough review of the proposed changes by qualified personnel and the implementation of any necessary safety measures. In conclusion, the proper classification and management of hazardous locations is essential for ensuring the safety of personnel and property. By adhering to the National Electrical Code and other applicable regulations, and by implementing robust safety procedures, it is possible to minimize the risks associated with flammable gases and vapors.